Hello everyone, welcome back to our channel. Today we're diving into an incredible piece of automotive history, the Chrysler Turbine Car. This groundbreaking vehicle could run on almost anything from gasoline to tequila. Stick around to learn all about this engineering marvel. Before we explore the Chrysler Turbine Car, let's take a brief look at two other engine types that have powered vehicles for decades: carburetor engines and fuel injection engines. Carburetor engines have been around since the early days of the automobile. The carburetor's main function is to mix air and fuel in the correct ratio before it enters the engine's combustion chambers. It uses a series of jets and valves to regulate this mixture, ensuring the engine runs smoothly. One of the advantages of carburetors is their simplicity. They are relatively easy to maintain and repair. However, they can be less efficient in terms of fuel consumption and emissions, especially compared to modern fuel injection systems. Fuel injection engines emerged as a significant improvement over carburetor engines. Instead of relying on mechanical components, fuel injectors use electronic control units, ECUs, to precisely manage the fuel-air mixture. This leads to better fuel efficiency, lower emissions, and improved performance. Fuel injection systems can adapt to various driving conditions, making them more versatile. However, they can be more complex and costly to maintain compared to carburetors. Another important engine type is the diesel engine. Unlike gasoline engines, diesel engines use compression ignition, where the air is compressed to a high pressure and fuel is injected into the compressed air, igniting it. Diesel engines are known for their fuel efficiency and torque. Diesel engines are commonly found in trucks, buses, and some cars, as well as in industrial and marine applications. They offer excellent fuel economy and long-lasting durability, but can produce higher emissions compared to gasoline engines. Rotary engines, also known as Wankel engines, use a unique design with a rotating triangular rotor instead of pistons. They run on gasoline and are known for their compact size and high power output. The most famous use of rotary engines is in the Mazda RX series of cars. Rotary engines offer a smooth and high-revving performance, but they can be less fuel efficient and may require more frequent maintenance compared to piston engines. Now let's shift back to our main topic. The Chrysler Turbine Engine was developed in the early 1960s. Chrysler's engineering team, led by George Hubner, aimed to create a more efficient and reliable alternative to traditional piston engines. The result was a gas turbine engine, which shares more in common with jet engines than with typical car engines. In 1963, Chrysler unveiled the Chrysler Turbine Car, a sleek and futuristic vehicle powered by the gas turbine engine. This car featured a striking bronze color and a design that highlighted its innovative technology. The turbine engine itself was a masterpiece of engineering, with a single-stage gasifier and power turbine, regenerators for improved efficiency, and a compact design that fit neatly under the hood. The development process was ambitious and challenging. Chrysler built numerous prototypes and conducted extensive testing to refine the design. The goal was to create an engine that was not only efficient and reliable, but also capable of running on a wide range of fuels. This versatility was one of the key motivations behind the project, as it offered the potential to reduce dependence on gasoline. How it works. Alright, let's break down the inner workings of the Chrysler turbine engine in a straightforward way. First off, think about how a jet engine works. The Chrysler turbine engine operates on a similar principle. It all starts with air being drawn into the engine through an intake. This air is then compressed by a component called a compressor. Imagine squeezing a balloon. By compressing the air, you're packing more air molecules into a smaller space, which is exactly what the compressor does. Next, this compressed air is mixed with fuel. The Chrysler turbine engine is quite versatile when it comes to fuel. It can use gasoline, diesel, kerosene, or even vegetable oil. There are even stories of the engine running on Chanel No. 5 perfume and tequila at fairs, showcasing its incredible flexibility. Once the air and fuel are mixed, they're ignited in a combustion chamber. Picture a thermal-controlled explosion happening inside the engine. This ignition process creates high-pressure, high-temperature exhaust gases. These gases then rush through a turbine, a series of blades that spin when hit by the high-pressure gases. The spinning turbine is connected to a shaft that ultimately drives the car's wheels. In essence, the force of the exhaust gases spinning the turbine is what powers the vehicle. But that's not all. The Chrysler Turbine Engine also has something called regenerators. These are heat exchangers that capture some of the heat from the exhaust gases and use it to preheat the incoming air. This makes the engine more efficient because it uses less fuel to reach the necessary temperature for combustion. To put it simply, air comes in, gets compressed, fuel is added and ignited, and the resulting high-pressure gases spin a turbine that powers the car. Plus, with the help of regenerators, it does this more efficiently by recycling some of the heat, producing about 130 brake horsepower and 425 pound-feet of torque. Now, let's talk about the advantages of the Chrysler Turbine Engine. 1. Fuel flexibility. The Chrysler Turbine Engine can run on various fuels, including gasoline, diesel, kerosene, and even vegetable oil. 2. Smooth operation. The engine produces minimal vibration, unlike the piston engines, offering a smoother driving experience. 3. Fewer moving parts. With fewer moving parts than a piston engine, the turbine engine requires less maintenance and is more reliable. 4. No need for a cooling system. Unlike traditional engines, the turbine engine doesn't require a radiator or cooling system. The engine components were designed to handle these high temperatures. Additionally, the engine used regenerators, which helped capture some of the heat from the exhaust gases and reused it to preheat the incoming air, making the process more efficient and reducing the overall heat generated within the engine. Challenges. Of course, there were some challenges as well. 1. High fuel consumption. Despite its fuel flexibility, the turbine engine was not as fuel efficient as hoped. 2. High emissions. The engine produced higher levels of nitrogen oxides, which contributed to air pollution. Cost. The technology was expensive to produce, making it difficult to bring the engine to market affordably. Response time. The throttle response of the turbine engine was slower compared to piston engines, affecting acceleration. And that brings us to the final part of our journey, the comparison and conclusion. When we compare the carburetor, fuel injection, diesel, rotary, and Chrysler turbine engine, each has its strengths and weaknesses. Carburetor and fuel injection engines are more responsive and fuel efficient compared to the Chrysler turbine engine, but lack its smoothness. Diesel engines offer greater efficiency and torque, but they lack the smoothness and fewer moving parts of the turbine engine. Rotary engines are compact and smooth running, yet they have higher emissions and maintenance requirements than the Chrysler turbine engine. The Chrysler turbine engine, with its innovative design and fuel flexibility, stands out. It could run on various fuels, even perfume and tequila. However, it was less fuel efficient and had higher emissions. Despite its challenges, the turbine engine remains a testament to automotive innovation, pushing the boundaries of what's possible. Thank you for watching our video. Please don't forget to share, hit like, and share your thought with us in comment section. May we meet again. Until then, goodbye.